Hey everyone, it's Justin again. In the last lesson, we learned theorems about angles when we know that we have parallel lines. In this lesson, we're going to work backwards and use those angles to show that the lines are parallel. By the end of this lesson, you should be able to determine if lines are parallel based on converse transversal theorems. First, we'll learn the difference between theorems and converses. Next, we'll discuss transversal theorem converses. Finally, we'll complete 2 practice problems. Converse is a word that you're going to hear a lot in this lesson. But what does it mean? In math, most of our theorems involve one thing causing another. One way we can think of this is that a theorem says, when A happens, then B happens. Does that structure remind you of the transversal theorems you learned in the last lesson? Let's use one of those as an example. Last lesson, we learned that when the 2 lines the transversal crosses are parallel, then the alternate exterior angles are congruent. Do you see how this follows the same structure? The converse flip-flops the 2 parts of a theorem. So it says that when B happens, that means that A happens. For that same example, that means our converse would say that when the alternate exterior angles are congruent, then the 2 lines the transversal crosses are parallel. You'll learn more about converses later in the course, including how to create them, and determine whether or not they're always true. But for this lesson, you just need to understand the vocabulary word. You'll find the full text of each of the converse theorems in your notes template PDF. But what they mean for us is this. If you have a transversal crossing 2 lines, and any of the alternate exterior angles, alternate interior angles, or corresponding angles are congruent, then we can conclude that the lines must be parallel. We can do something similar with consecutive interior angles. If you have consecutive interior angles that are supplementary, then the lines must be parallel. You only have to know any one out of these 4 relationships to say that the lines are parallel. Did you notice that vertical angles weren't included on the last slide? As you learned in Unit 1, vertical angles are congruent at any intersection. I could have congruent vertical angles with a transversal crossing parallel lines, but I could also have congruent vertical angles with a transversal crossing lines that aren't parallel. Sadly, vertical angles being congruent doesn't tell us anything about whether or not our lines are parallel. So there's no converse for this angle pair. Let's recap the difference between these theorems and their converses. In our last lesson, we learned theorems that said, if the lines that a transversal is crossing are parallel, then the special angle pairs they create are congruent or supplementary, depending on the pair. The converses let us go in reverse. They say that if the special angle pairs are congruent or supplementary, depending on the pair, then the lines that the transversal is crossing are parallel. Let's check out what these converses let us do. So let's put this into action. Notice that we have not been told that lines A and B are parallel in this diagram. There are no arrows on the lines, and there's no other information given. If we want to be able to say that these lines are parallel, we're going to have to justify it. Here's the first question. If angle 6 is congruent to angle 7, do you have enough information to determine that line A is parallel to line B? If so, how? Okay, so let's take a look. Here are angles 6 and 7. What is their relationship? They're vertical angles. Does vertical angles being congruent prove that lines A and B are parallel? No, it doesn't. The vertical angles here would still be congruent even if lines A and B were not parallel. Let's try another one. If the measure of angle 3 is 74 degrees and the measure of angle 5 is 106 degrees, do you have enough information to determine that line A is parallel to line B? If so, how? Well, here are angles 3 and 5. What's their relationship? They're consecutive interior angles. What does the consecutive interior angles theorem, converse, tell us? Feel free to check the theorem in your notes. If the consecutive interior angles 3 and 5 are supplementary, then lines A and B must be parallel. So what do you think? Can we say that line A is parallel to line B here? If we add their measures together, 74 plus 106 makes 180 total degrees. That means they are supplementary, so yes, the lines are parallel. Then we're also asked how we know. So which theorem, or converse, tells us that based on this information, the lines are parallel? The consecutive interior angle theorem, converse. Here's a new diagram. Our first question with this diagram says if the measure of angle 2 is 53 degrees and the measure of angle 7 is 53 degrees, do you have enough information to determine that line C is parallel to line D? If so, how? Give this one a try on your own, and then we'll go over it together. Angles 2 and 7 are these angles in our diagram. Did you notice that they have a corresponding relationship? Because they're two corresponding angles that are congruent, we can say that yes, we can determine that these lines are parallel by using the corresponding angles theorem, converse. Nice job. Now how about this one? If the measure of angle 6 is 127 degrees, the measure of angle 3 is 90 degrees, and the measure of angle 4 is 37 degrees, do you have enough information to determine that line C is parallel to line D? If so, how? Take a look here. Angles 3 and 4 look a little bit different on this diagram. Individually, neither of them are actually formed by the transversal crossing line D. In fact, when the transversal crosses line D, it creates this big angle that combines angles 3 and 4. With that in mind, try this problem on your own. Did you realize that if we combine angles 3 and 4, the measure of this larger angle would be 90 degrees plus 37 degrees, which makes 127 degrees? Now that is congruent to angle 6. And angle 6 and this larger angle are alternate interior angles. Since they're congruent, we can say that yes, we do know that lines C and D are parallel because of the alternate interior angles theorem, converse. Now you can identify theorems and their converses. And you can also use those converses to help prove whether or not the lines crossed by a transversal are parallel. See you next time. Hey.